multiples of 2. Help me know my multiples of 4. What is that multiples of 2? What does that mean? What am I talking about when I say multiples of 2? Michael?
Like adding a number times 2.
Okay. Going to want to add on to that?
2's multiplication.
Yeah, I'm talking about my 2's timetables. You already know them. You can skip count by 2. Let's skip count by 2's. Ready? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We'll stop. Yeah, my multiples of 2 just mean my skip count by 2's. This means my skip counts by 2's. That's what I'm talking about. So when I say multiples of 4, what do you think we're talking about then? When I say multiples of 4, what do you think we're going to be talking about? John?
Skip counting by 4.
Skip counting by 4's. But I'm talking about multiples of 4. I'm going to be using those same skip counts. Whoops. But this time I'm going to be going by 4's. Now, most of us aren't great skip counters by 4. We could probably do 4, 8, 12 maybe. Some of you are great skip counters of 4. That's a great strategy. I will go ahead and tell you it's not my strategy. I'm not a skip counter by 4. Can I kind of struggle through it? Yes, but it's not something that comes easy to me. It might come easy to you, and that's great. So what we're going to do instead of trying to memorize how to skip count by 4's is I'm going to show you a little trick. Because you are good skip counters by 2's, we're going to use that to help us be better at our 4's. Michael, what do you think?
So it's like we're using the 2's and 4's so we can skip count by 2's, but still like skip count by 4.
John?
I gotta know count 2.
Absolutely not.
How you skip count by 4. 2 is 4.
Yeah, we've got a relationship already between our 2's and our 4's. So most of you can probably see how they might be related. Alright, so what we're going to do now, you can move your notebook down to the floor, put your pencil in it, close it, put it on the floor, that way it's in your spot. Get out your counters. You can get out all of them, that's fine. I'll give you some seconds to get out your counters. Please make sure with your yellow counters, I want you to build a 2 by 2 array. 2 by 2, or 2 groups of 2. When you do that, above it or below it with your marker, go ahead and write the equation that matches a 2 by 2 array. Get right on your desk, sorry. Is that what you're asking? Yeah. Get on your desk, yeah. Just like whoever does not have their mic muted, if you could please mute your mic, that would be very helpful. Sorry. Remember, an array is rows and columns. We still see our 2 groups of 2, but we've arranged them into rows and columns. And then with our marker, we should have that is a 2 by 2. We might also read this equation, Jacob, as 2 groups of 2. Right? Now remember, we're going to use our 2's to help us with our 4's. Sean already told us, hey, when I take my 2's, if I just double it, I get to 4. So now I want you to make the same array, but I want you to make it in red. So there's a 2 by 2, don't move that one, keep it there. But now I want you to make the same thing next to it in red. doing is I'm turning all of them one color. What equation do I have now? What equation do I have now, Lincoln? Keep going. Love it. Now I have 4 groups of 2. I did that because I made 2 groups of 2 plus another 2 groups of 2. What was 2 groups of 2 equal to? How many counters were in 2 groups of 2 when you made a 2 by 2? Bladen? 4. So I had 4 plus another 4. So what does 4 groups of 2 equal?
If we doubled it, it would have been 16.
What does 4 groups of 2 equal? Ashley? 8. See how I did that? How I doubled? Let's try another one. Go ahead and move your counters to a blob. Go ahead and just move your counters to a blob.
We erase all this.
No, you can leave your writing. That's fine. This time, we're going to make a 2 by 5. Make a 2 by 5. Make a 2 by 5. You can make it in whatever color you want. Just make one color. So if you want to make it red, that's fine. If you want to make it yellow, that's fine. Please make a 2 by 5. You should not have 4 markers out. You get 1 marker. You're making a 2 by 5. I think I'm going to use red for mine. Here's my 2 rows. And I'm going to keep going until I have 5 columns. Now, some of you, like I see Bladen, his array looks just like mine, but his is up and down. Is that wrong?
No.
No. If I pick Bladen up and I turn him sideways, is he still Bladen?
No.
Yes, he is still Bladen. And we know that we can rearrange those factors, meaning I can build my array sideways, and my product, my answer is not going to change. This is a 2 by 5. What does a 2 by 5 equal? Absolutely not. You've lost your privilege. Sorry. You can do it in your notebook. Get your notebook out. We have a 2. Get your notebook out. It's on the ground. We have a 2 by 5. What does that equal? You have those counters there. Can you count them? Yeah. What does it equal? Bigger? Yeah. What does that equal? How many total things is that? 10. What do you think would happen if I wanted to make this 4 by 5? If I doubled it, if I made a whole nother 2 groups of 5, what do you think would happen? Jacob, sit up. Bladen, what do you think would happen?
I think it would just double the answer number, because if you add another full group of 10, it's the equal number, so if you have 10 plus 10 it equals 20.
Yes! Did you hear that? That was awesome. Bladen said, hey, I'm just going to double my answer to my 2 times 5 because I know that I'm just going to build another one of those 2 times 5. So I need to double my answer. So what is it going to be? 4 times 5 is what?
20.
20!
Because there's 2 groups of 10.
There is 2 groups of 10. I love how you said that. I love how you said that. Yes.
I get it now because it's double. Because if you double it up, 2 plus 2, 4, you just doubled it up. So then that's still. So then that just makes one more 10.
Exactly. Exactly. Alright, we're not going to use our counters for the next one, but we are going to continue to write on our desk. So move your counters out of the way. We're going to write these two equations right on top of each other. The first one we're going to do is 2 times 7 equals. When you know the product of 2 times 7, go ahead and raise your hand. 2 times 7. And remember, if you don't know, can you skip count?
Yes.
7 times? Yep, you can. 2 times 7. What is that going to equal? Gwen?
The answer is 14, and I'm going to say that it's like with the 2.
Uh-huh.
It's like there's the number after the 2.
Yep.
And counting it over and counting it again.
Yeah.
I could not.
Exactly. We're doubling it. That's exactly what we're doing.
Really tired.
Alright, now what about 4 times 7?
Ooh.
Can you figure that out?
And also on the first one, so you see how 7's at the end?
Mhm.
You're clearly just doubling that.
I am. 4 times
You can
7.
also do it the other way.
Use your 2s. I know you're not great at skip counting by 4s. That's okay. How can you use those 2s? Jackson, what'd you get?
28.
How did you do it?
Because I realized that 4 times 7, it's just like 4 times 2, but 2
2
more
times 7.
times. So I did, and I know that 2 plus 7 equals 14. So
Yep.
there's 2 of that, and I add 14 together, and it made that number.
Wow, awesome job. Nice. Yeah, did you hear what he said? Jackson said I knew 2 groups of 7 was 14. And I just needed to do that again. Double it again. 14 plus 14 gives me 28. That's a bigger one. Ready?
6? Yeah.
2 times 11.
Oh, I thought that was a 6.
Ooh, 2 times 11.
Okay.
You don't know, skip count by those 2s. You got those. I know you know how to do those. 2 times 11. Victor's using his counters. It's a solid strategy. I'm here for it. 2 times 11. Lincoln, what did you get? 22. 22. Alright, how can I use that to figure out 4 times 11?
Oh, you're just gonna...
How can I use that to figure out 4 times 11? Victor, you know what it is?
I think it's 24.
22 is 2 times 11. Very good. Gwen, did you figure out 4 times 11?
Yes. The way that I found out though is I took 22 and I added another 22.
Love. Yeah, Gwen said I know 2 groups of 11 is 22, and I need 2 more groups of 11, so I'm going to add another 22. What'd you get?
44. It's all equaling with some...
I'm going to do a really big one. Are you ready?
Ooh, okay.
Because you totally
Like
can.
2 times 11.
Yep, 2 times 11 is 22.
And
I
also
had 4
2 times...
Wait, you're on 2 times.
Oh, I just noticed that every single one, it's always equal.
What is it?
Oh, no.
Alright, so our next one is going to be a big one.
Okay. Oh,
It's
no.
going to be a challenging one.
Okay.
2 times 100.
Oh, I know the answer already.
It might actually be the easiest one.
What is 2 times 100? Now, if you're thinking, that means I got to skip count by 2s 100 times.
No. You could use the
I wouldn't. I would read it and think about what that looks like. 2 groups of 100. What does that look like, Bella? What is the answer? Yep. 200.
Because you're probably doubling one.
What about your
the
group
one that was the
of 100? 4 times 100.
Oh, okay.
4 times 100. Ashlyn? 400. Whoa.
We're getting some pretty high numbers.
You are getting into some high numbers. Shelby?
I realized whenever 2 times something,
Uh-huh.
it always just doubles it.
It did. It did. Yeah.
I think this is what Shelby just said, but at the end, like in the ones place, every time you
What
have like
was it?
2 or an even number on these, it's most likely to have an
400.
even number at the orange.
Yep. Yep. So Bladen, notice, hey, when I multiply by 2s and when I multiply by 4s, I'm getting a lot of even numbers.
At the end.
Yep. Yep. Very good. All right, we are going to pause on our desk. Don't put your stuff away. We're going to come back to it. But I want you to get out your notebook and turn to that hundreds chart that we did yesterday. This is the one that had all of those 2s colored in. We did it in yellow. Yep, can I borrow your stack pen? This is the one that we're looking at. Yep. Should be pretty close to what we did today. I want you to get out a blue crayon today. I want you to get out a blue crayon. And we're going to add our 4s right on top of our 2s.
What is this in the blue for some
All right. Nope. All right, what is 4 times 1? What is 4 times 1? This is not a trick question. 4 times 1. Victor?
4.
You have one group of 4. How many do you have?
I know it
One group with 4 dots in it. How many do you have? 4. Take that blue marker, color in that 4. Hey, that 4 is already colored yellow. I know. Watch what's going to happen.
Oh.
It should start to color green because blue and yellow make green. And if it's more of a blue color, that's okay. Fine.
Oh, it's sort of green.
What is 2 times 4?
Yes, sort of green.
2 times 4. 2 times 4. John? 8. Color in our 8.
What's the blue?
Yep.
Oh, color light.
Sure. What about 3 groups of 4? Another way you can do it is see where we left off on 8. I'm going to count 4 more. Ready? 1, 2, 3, 4. I landed on number 12. And then I'm going to count 4 more. Ready? 1, 2, 3, 4. I landed on 16. Hey, did you notice that all of my 4s so far have landed on a 2?
Yeah.
Are you noticing any other patterns?
No.
Will, are you noticing any other patterns?
They only land on even numbers.
They do only land on even numbers. Very true. Michael?
They skip one of the colored yellow ones.
Yeah. So we have 2s, that first yellow one, and then 2s and 4s. 2s, 2s and 4s. 2s, 2s and 4s. 2s, 2s and 4s. What do you think this one's going to be? 2s. What about 20? 2s and 4s. Go ahead and color it. What about 22? So it's going to be 2's only.
No.
And then 24 is 2's and 4's.
So 24.
26 is going to be 2's only. 28. 2's and 4's. I'll give you some seconds to finish. Take your time. We don't want to be coloring the wrong thing.
Finish the whole thing.
You can finish the whole thing. Take your time. If you need help, you can always stop at the last one you colored and count on 4 to figure out the next one that you color. Which one of those numbers is a part? Like it? 3? What about the 4? Is that a part or a whole? Tell me. Part times part will always give me my whole. I'm going to use that to figure out my division equation. Now, I can't type the division symbol, this division symbol. I can't type this on the computer. It doesn't exist. So when I'm typing division, I will use this symbol. They mean the same thing. It just depends on what kind of computer. You're going to have a special computer to type this symbol. Your laptop doesn't have that button. My laptop doesn't have that button.
Is it for like a working computer?
You'd have to have a special Mac computer. Okay. So this right here reads 20 divided by 4. When I'm dividing something, do I start with some of it or do I start with all of it?
All of it.
All of it. Above 20 divided by 4. Go ahead and write 20 divided by 4 in your notebook. I want you to write W. Because your 20 is the whole. We always, when we're dividing or dealing out, we're always starting with all the things. That means my 4 is a part. And that means my answer is also a part. I'm going to use that. And I'm going to write a multiplication equation. My multiplication equation is going to start with a part. You see how it has a P right there?
Yeah.
Which part you want to start with? Doesn't matter. You can start with either one of them. Will?
The 4.
Okay. 4. I'm multiplying now, so my symbol changes. My other part is missing. It's just a box. Go ahead and put a box there. That's going to be my number saver. I know a number goes there, I just don't know what number that is yet. 4 times something equals, what's my whole? Do you know what times 4 gives me 20? Do you know that one? Victor, do you know it? Or do you have a question?
Is that all? It's like, in the answer, that the 4 times blank equals 20. It's like in some answers that you think it's, that you're supposed to put the answer, but you actually have to put the missing number.
You're exactly right. Victor brought up a good point. He said, hey, sometimes, actually lots of times, we're used to filling in the part right after the equal sign. But in this equation right here, we already have a number right after the equal sign. We're not filling in what it equals. We already know that. It's 20. We got to fill in that missing number. Jackson, do you know what's going to go there? 4 times 10. All right, let's skip count by 10s. Ready?
5.
All right, skip count by 5s.
5, 10, 15, 20.
Is it 5?
Yeah.
Did you see Jackson? He said 10 first. And then when we skip counted, he goes, oh, that was too big. I need a number smaller. So then he went with 5. So that was a brilliant strategy. And did 5s work?
Yes.
Yes. So did we do any division?
Yes.
No, you
we just
We
got
just
the
used
numbers.
some skip counting and some multiplication, even though we were solving a division problem. Isn't that crazy? That's crazy. In my experience, in my brain, multiplication is easier for me. That's just mine. So when I come across a division problem, I try to make it a multiplication problem. Just because that's easier for my brain. If I have things in front of me like counters, I can deal out, that'll work. I can do circles and dots, that'll work. But if it's something like this, I might try and see if I can make it a multiplication equation. Does that make sense?